welcome to the introductory lesson on time, speed and distance. In this video, we are going to discuss how we can solve problems by keeping time, speed or distance constant. Now let us begin with our today's lesson. Now, in order to solve questions related to time, speed and distance, we need to know its formula, which is time into speed is equal to distance. Time can be measured in hours, minutes or seconds. Kindly note that 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. Therefore, 1 hour is equal to 60 minutes into 60 seconds, which is equal to 3600 seconds. Speed can be measured in miles per hour, kilometers per hour or meters per second. Kindly also note that 1 kilometer per hour is equal to 1000 meters divided by 3600 seconds, which is equal to 5/18 meters per second. We will now look at the different scenarios in order to solve problems accordingly. We will first look at how time and distance increase or decrease if the speed remains constant. So, if speed is constant and if time increases, distance will also increase. This implies that time is directly proportional to distance, provided speed is constant. This can further be elaborated with the help of an example, which says that if A travels at a speed of 20 kilometers per hour for 2 hours, how much distance will A cover with the same speed if A travels for 4 hours? Now we know that time into speed is equal to distance. And if A travels for 2 hours at a speed of 20 kilometers per hour, A is going to cover a distance of 40 kilometers. Now, with the same speed, that is 20 kilometers per hour, if A travels for 4 hours, A is going to cover a distance of 80 kilometers. This implies that if speed is constant, then if T is multiplied by K, D will also be multiplied by K. Right? Now, there is another question which says that if Adam travels 50% more, then he takes 1 hour more. Calculate the actual time taken to travel the distance. So over here, speed is constant, right? And the question says that if Adam travels 50% more, then he takes 1 hour more, which means that 150% of D would be 1.5 into D or 3/2 into D. Now, T would be, if D is increasing, right? If D is increased by 150%, it means that time will also be increased by 150%, which means that time will also be multiplied by 3/2. And we have been given that it takes 1 hour more, right? If Adam travels 50% more. So 3/2 T minus T, which is the actual time, is equal to 1 hour, right? And if we simplify it, we're going to get T is equal to 2 hours. That is the actual time taken to travel the distance. Now, in the second scenario, we are going to keep distance constant. So if speed increases, time will decrease, which implies that speed is inversely proportional to time, provided distance is constant. Now you see we have an example here which says A travels a distance of 20 kilometers in 1 hour. If A doubles the speed, in how much time will he cover the same distance? Now we know that time into speed is equal to distance, and over here distance is constant, that is, it is 20 kilometers. So if it takes 1 hour to cover a distance of 20 kilometers, that means that A is traveling at a speed of 20 kilometers per hour. Now the question says A doubles the speed, which means that the speed, which is 20 kilometers, is going to be multiplied by 2, right? And at the same time, the time, that is 1 hour, is going to be divided by 2, right? Because speed and time are inversely proportional, right? So if one is increasing, the other would automatically decrease, provided distance is constant. So distance is constant here, that is 20 kilometers, and our answer would be half an hour, right? So A is going to cover the same distance, that is 20 kilometers, in half an hour. Now you see, this implies that if distance is constant and if speed is multiplied by a number, that is k, then t would be divided by the same number, that is k. Similarly, if distance is constant and time is multiplied by k, which is any number, then speed will be divided by the same number, that is k. We will now look at how we can solve a question if distance remains constant and speed increases. The problem over here says that if speed of a car is multiplied by 4/3, then 10 minutes are saved. So you see, if speed is increasing, that means the time taken to cover a distance will automatically decrease. Calculate the usual time taken to cover the distance. Now you see, the distance is constant here, but speed is being multiplied by 4/3. So if speed is multiplied by 4/3, that means time is going to be multiplied by 3/4. That is the inverse of 4/3, right? And we have been told that the time saved is 10 minutes if we increase the speed. So the actual time minus the new time, that is 3/4t, is equal to 10 minutes. And if we simplify it, we're going to get 40 minutes, which is the usual time taken to cover the distance. And our new time would be, that is, if we increase the speed by 4/3, then we'll cover the same distance in 30 minutes, that is in half an hour, right? We will now see at the third and the last scenario where time is kept constant. So if time is constant and if speed increases, the distance will also increase, which implies that speed is directly proportional to distance, provided time is constant. Now, this means that if speed is multiplied by k, that is any number, then d will also be multiplied by k. Or if speed is divided by any number, that is k, then distance would also be divided by the same number, that is k. Right? Now, there is a problem which says that if A travels for 50% more speed, then A travels 15 kilometers more. Calculate the actual distance. Now you say A travels for 50% more speed. So automatically the distance covered will also increase, right? And over here the time is constant. So 50% more means 1.5 or 3/2. So speed is going to be multiplied by, that is the actual speed is going to multiply by 3/2, which means that the distance is also going to be multiplied by 3/2, right? And the distance traveled after the speed is increased is 15 kilometers more, which means that 3/2d minus d, that is the actual distance, is equal to 15 kilometers, right? And if we simplify it, we're going to get d, that is the actual distance, equal to 30 kilometers, right? Now, this question, the same question can be solved in another way. That is, 50% of D is equal to 15. So if 50% of D is equal to 15, then D would be equal to 30 kilometers, right? Sarah travels at 30 kilometers per hour for the first 2 hours and 40 kilometers per hour for the next 2 hours. Find the ratio of the distance traveled. Now, you see we can solve this problem in 2 ways. The first way is to put the values in the formula of time, speed and distance and finding the answer. And the second way is the very, it's a very direct way of solving the question. But first, have a look at how we can solve this problem by putting the value in the time, speed and distance formula. Okay, now we know the time into speed is equal to distance. So for the first 2 hours, Sarah traveling at 30 kilometers per hour is going to cover a distance of 60 kilometers. And in the next 2 hours, with the speed of 40 kilometers per hour, she's going to cover a distance of 80 kilometers. So the ratio of distance traveled is going to be 60 to 80, which is equal to 3 to 4 or 3 over 4, right? Now, solving the question in the direct way or in the easiest way possible is to see what is constant here. Now, the time is constant here, which is 2 hours, right? So, what we're going to do is that if t is constant and the speed increases, this means that d will also increase. And this means that d1 over d2 is going to be equal to S1 over S2, which is equal to 30 over 40 or 3 over 4. So our answer is going to be the same, that is 3:4, right? With this, we come to the end of our first video tutorial on time, speed and distance. The reason why I have explained different scenarios in this video is for you to solve the problems based on this topic easily and efficiently. I hope you have understood it well. In case of any confusion, just drop a question under the comments and I will try my best to reply to you as soon as possible. So goodbye for now and have a very nice day. Stay positive. Good luck to you. Thank you.